Welcome once again to this YouTube channel, and congratulations to all those students who excelled in the recently released IGCSE Chemistry Major series. Just by watching our videos, they have been able to come out in flying colors. We have several testimonies of excellent results. For those who will be needing personal tutoring, at the end of this video as well, be posting certain information that you could use to reach out to me.
This is what we do in the masterclass, really. We try as much as possible to ensure that we're able to properly, teach learners how they can properly understand, interpret the question as much as possible. We dive deeper than just a past paper to ensure that at the end of the day, they're able to fully understand any question that is being administered to them.
All right, so in this particular video, we are going to be solving the May June 2024 IGCSE Chemistry. So let's dive into solving these questions. All right, so the first question here talks about naming the processes involved in each of these questions. So the first one says, name the process that is used to convert sulfur dioxide into sulfur trioxide in the manufacture of sulfuric acid. So you need to realize or remember that in the manufacture of sulfuric acid, the process there is the contact process. So it's basically the contact process. So the contact process is used for the manufacture of sulfuric acid, where you use where you roast sulfur dioxide in air to obtain sulfur trioxide using the vanadium 5 oxide as the catalyst, using the pressure of about 280 m, okay, and a temperature of about 450 degrees Celsius. So that's basically the second step of in the manufacture of sulfuric acid, and that's titled the contact process. The second one is you obtain water from aqueous sodium chloride. Okay, so distillation is used here to obtain water from aqueous sodium chloride. To extract aluminium from purified bauxite, that is electrolysis, and we always say that it is the most preferred process because aluminium is more reactive than carbon, so you cannot use the blast furnace method for this. All right, the next one says the process used to separate petroleum into useful substances. Of course, you know that is fractional distillation. So fractional distillation is the method or process adopted here. To produce ethanol from aqueous glucose, all right, just for the fact that glucose was mentioned, so to obtain ethanol from glucose, that's the process of fermentation. So fermentation where yeast is involved and a very optimum temperature as well. To manufacture alkenes and hydrogen from large alkane molecules, that's cracking, all right, that's cracking. Remember, cracking, one of the templates for cracking is you obtain smaller alkenes and hydrogen, or you could obtain just alkenes, just two smaller alkenes. To separate a mixture of soluble colored substances, wherever colored substances are involved, it's chromatography. So chromatography. So this is as easy as it gets for the first question there. All right, so let's go to the second question. All right, for the second question, we have a table where you're asked to complete. All right, so to complete this table, you need to understand that when you're talking about a neutral atom, when you have a neutral atom, right, in a neutral atom, the number of protons is equal to the number of electrons. All right, so this would help as well to solve this, complete this table. So for the first one here, we have a neutral atom, which is the chlorine atom, and the number of protons is just the number below, while the one on top is the mass number. All right, so the number of protons automatically becomes 17 because it's a neutral. You see that it's a neutral atom, and then we have the proton number clearly stated there. Then to obtain the number of neutrons is simply the mass number minus the proton number. Okay, so in this case, the mass number is 37 minus 17, So if you deduct that, you should have 20. So 20 right here. Okay, for the second one, where we have the copper cation, you see that the copper there is not a neutral atom, is rather a charged atom. So it's an ion, a cation precisely. So the number of protons remains the same in a charged ion, so it's basically 29, but the number of electrons changes. So the copper cation having a plus charge means that the copper has lost an electron. So basically, the number of electrons will become the proton number minus 1, since this is just a single charge that is there. So by the time you deduct that, you have 28. So when there is a positive charge, it means it has given out a single electron, and therefore the number of electrons there is 28. Okay, for the last one, we have to complete the atom or ion column precisely. So from the number of protons, we can know what kind of element is it. So from a proton number of 16, that should tell you it is sulfur. So sulfur has a proton number of 16. So we can basically write 16 right here as the proton number. All right. So we are also told that the mass number of this, to get obtain the mass number of this atom or ion, as the case may be, it has to be 16 plus 17. So we are going to add, for the mass number, is going to be 16 plus 17. So that's basically 33. So we could boldly write 33 right here. Okay, so after doing that, the next thing is to looking at what we said earlier, that the number of protons should be equal to the number of electrons if it were a neutral atom. But in this case, the number of protons is not equal to the number of electrons. That means it is not a neutral atom. So we see that the number of electrons is 18 and the number of protons is 16. So that should tell you that the sulfur has gained 2 electrons. Okay, it has gained 2 electrons. So for it to have gained 2 electrons, it becomes 2 minus. So it's S2 minus. And that's as easy as that gets. So these questions are quite easy for you to easily excel. Okay, this is question 3. Sodium reacts with fluorine to form sodium fluoride. Write the symbol equation for this reaction. Okay, you know sodium is in group 1, and you know that the group 1 elements are simply monoatomic. Okay, so sodium has a symbol of Na, right? It's monoatomic, plus. Now, fluoride is gotten from fluorine, all right? And you know that the halogens are diatomic. So we have F2, Bl2, Cl2, I2. All of these are diatomic in nature. So you need to realize that, and we're just fixing the F2 here. So other elements that can behave this way are like oxygen, hydrogen, always diatomic, nitrogen equally as a diatomic. So by the time this reacts, all right, we want to see the product. So the product should be sodium fluoride. But how do we write sodium fluoride? Now, sodium is in group 1, so it has a charge of +1. The fluoride ions always have a negative charge. They're in group 7, but a negative charge. So by the time they interchange their powers, okay, excluding the charge. So it's basically Na1F1. So that's NaF. Basically NaF. All right. So this is the correct formula of sodium fluoride, but we need to balance the equation. All right. So we could put a 2 here, all right, so that there are 2 sodiums on the right, and then we balance it with 2 sodiums on the left. And the number of fluorine atoms is equally balanced. And that is how to solve that question. All right. So moving to the next question, we have the table, and we asked to explain why sodium conducts electricity when it's a solid. Now, you recall that sodium is a metal, and metals, from the description of the metallic bond, you know that there are it's a lattice structure of positive ions. So the metal is a lattice structure of positive ions, okay, and these positive ions are surrounded by delocalized electrons. All right, so let's just get this diagram. So this is a lattice, a regular arrange positive ions surrounded, so the metallic bond is simply surrounded by delocalized electrons. So these are the delocalized electrons surrounding the positive ions, and they are simply held together. That is, the delocalized electrons and the positive ions are held together by an electrostatic attraction. All right, so the reason why a metal, considering this diagram, would conduct electricity is because of the localized electrons. That is, the electrons are mobile. Okay, so sodium is a metal. It conducts electricity when it's a solid because it conducts due to the mobile electrons. So either we say mobile or we say delocalized. So the electrons are moving, and therefore it enables the conduction of electricity. Okay, so moving forward, we have this question where we have to complete this diagram. So to complete this diagram, okay, remember that fluorine has a proton number of 9. And if it has a proton number of 9, the configuration is simply 2 electrons and 7 electrons. So 2, 7. All right, so we are asked to just show the outer shell. All right, so we are not going to show this, we'll just show this. So it has to be a dot and cross diagram. So let's start with a dot for the first fluorine atom. So we are going to draw 7 outer electrons. So 1, 2, 3, 4, 5, 6, 7. All right, and then for the second fluorine atom, we're going to use the cross. So 1, 2, 3, 4, 5, 6, 7. So this is a covalent bond existing between the 2 atoms of fluorine, and that should get you the full mark for that question. All right, so the next question says, deduce the physical state of fluorine at minus 200 degrees Celsius. So I'm going to give the state and give an explanation why we pick that particular answer. So at minus 200 degrees Celsius, let's look at the table. So our focus is on fluorine. Now at minus 200 degrees Celsius, we see that minus 200 degrees Celsius is greater than the melting point of fluorine. So since it is greater than the melting point of fluorine, therefore fluorine at that temperature would be a liquid. Okay, so it's going to be a liquid. All right, now what's the reason why it's a liquid? Like we said, it is greater than the melting point of fluorine but lower than the boiling point. So assuming it was also greater than the boiling point, then it would have been a gas. But since it is greater than the melting point and lower than the boiling point, that simply makes it a liquid. So we'll basically write at that temperature, at minus 200 degrees Celsius, or we could say minus 200 degrees Celsius is, okay, let's put it this way. Okay, so minus 200 degrees Celsius is greater than the melting point. It's greater than the melting point of fluorine. And lower than the boiling point. So that makes it a liquid. So like we said, if it were higher than the boiling point as well, it becomes a gas because it has simply transitioned to a gaseous phase. All right, moving to the next question. Explain in terms of structure and bonding why sodium fluoride has a higher melting point than fluorine. So this is for 3 marks, and we have to compare 2 compounds using their structure and the kind of bonding that they undergo. So basically, you see that this is an ionic compound, therefore it has ionic bond. So this is an ionic structure, while this is a covalent structure. So that should be noted. So we're going to do comparisons and ensure that we write what would get us the required mark. All right, so we're going to write this now. We'd say sodium fluoride is an ionic structure. Sodium fluoride is an ionic structure, okay, with strong attraction, okay, with strong electrostatic attraction between the molecules. Okay, while fluorine is a covalent structure with weak intermolecular forces between the molecules. So this is a perfect description of explaining in terms of structure and bonding why the sodium fluoride has a higher melting point than fluorine. All right, so that's for that. So moving to the next question. Dilute aqueous sodium fluoride undergoes electrolysis. Hydrogen is produced at the cathode. So what is meant by the term electrolysis? This is always repeated. So students, learners should always prepare for this question. So electrolysis is simply, electrolysis is the breakdown. Electrolysis is the breakdown of an ionic compound. The breakdown of an ionic compound in the molten or aqueous states, right, by passing electricity through it. Okay, so for when you're defining electrolysis or you're explaining the term electrolysis, you have to mention that it is the breakdown of not just any kind of compound. It has to be an ionic compound. And that ionic compound needs to be in the molten or the aqueous state by simply passing electricity through it. So there are basic things you need to mention. First is the breakdown of an ionic compound. You also have to mention that it has to be in the molten or aqueous state. And you also have to mention that this is done by passing electricity through that compound. All right, so the next question, you have to write ionic half equation for the production of hydrogen at the cathode. So we're looking at dilute aqueous sodium fluoride at the electrolyte. So there are sodium ions there, there are hydrogen ions, there are fluoride ion, and then we have the hydroxide ion. But our focus is at the cathode this time. The cathode is the negative electrode, so it attracts the positive ion. So hydrogen is deposited at the cathode. And at the cathode, what goes on is reduction. So gaining of electrons occurs at the cathode. So hydrogen ion would gain electron. And you know, hydrogen is always in the diatomic state, so it's this way. And then all we need to do is just balance the equation. So we put a 2 here, and we put a 2 here to balance the charge, because the charge on the right is 0. So to get the charge on the left to be 0 is 2 from here minus the 2 electrons here. So this would get you the 2 marks for that question. Okay, so moving to the next one, we have question 4, where we have a lot of description here, all right, about the experiment. So the first question says, what is meant by the term equilibrium? This is also a question that is always repeated. So you need to equally prepare for a question like this. So equilibrium is the state where the rate okay, where the rate of the forward reaction, is equal to the rate of the backward reaction. Is equal to the rate of the backward reaction. Okay, so this is just the first point you need to state to get just 1 mark. Remember, it is for 2 marks. Then you also need to state the second condition for equilibrium. Okay, so we're going to say, and the concentration of reactants, okay, I have to raise this, the concentration of reactants, not reaction. Okay, the concentration of reactants and products are constant. So these are the 2 conditions for equilibrium. First is that the rate of the forward reaction is equal to the rate of the backward reaction. You also have to include, and the concentration of reactant and products are constant. What it means is that the concentrations are not changing. That is, they are no longer changing. So you have to be careful here. Do not write the concentration of reactants and products are the same. They are not the same. They are just no longer changing. They just remain constant. All right, so this is very important for when you're asked to explain what equilibrium is all about. All right, so we go further to look at other parts of the question. It says, the pressure of the mixture is increased, all other conditions stays the same. The position of equilibrium does not change. All right, explain why the position of equilibrium does not change after you increased the pressure. Now, the factor of pressure is dependent on the volumes or moles of reacting species. So let's get the moles of reacting species. So on the side of the reactant, we have just 2 moles of reacting species. And then on the product side, that's on the right, we have 1 plus, that's 1 here, coefficient of 1, so 1 and 1 here. So if we sum that up, that's about 2 as well. So 2 moles equally on the right. So we have 2 moles on the left, and we also have 2 moles on the right. Now, since they have equal number of moles, the pressure will not affect the position of equilibrium because there are equal number of moles on the reactant end and on the product end. So let's put that now. So the question now says, explain why the position of equilibrium does not change. It does not change. It does not change. It does not change due to equal number of gaseous. Okay, equal moles. Let's say they do not change due to equal moles. Let's erase this. Equal moles of gaseous reactants. And products. So when we're explaining pressure, our focus is on the gaseous reactants, not all the reactants in different states. You have to aim for only the gaseous reactants. That's why it's important that you mention the states of the reactants and the products. So that is why pressure doesn't affect that equilibrium position. Suggest why the color of the mixture of gases turns darker purple. All right, so looking at the products, we have one of the products, that's iodine gas, to be purple gas, and we have the hydrogen gas to be colorless gas. So it becomes darker purple because the particles of the iodine have been forced closer together. So when they have been forced closer together, the color becomes darker. Okay, so it becomes darker. because the particles, or we could say the molecules, have been forced closer, together. All right, so when the particles or the molecules come very close together, the color becomes darker. All right, so let's go to the next one. The temperature of the mixture of gases is decreased. All other conditions stays the same. The mixture of gases turns lighter purple. States what can be deduced about the forward reaction from this information. All right, so let's look at what has been done to the reaction again. The temperature has been decreased. All other conditions remain constant. Now, when it was decreased, we observed that the color of the gas turns lighter purple. So turning lighter purple simply means equilibrium shifted to the left. All right, so it means the equilibrium has shifted to the left. So when we talk about temperature in terms of our reaction, we are looking at either endothermic reaction or exothermic. All right, so if you can recall that when you increase the temperature of an endothermic reaction, that's a positive enthalpy, all right, and this is a negative enthalpy change. All right, so when you increase the temperature of an endothermic reaction, equilibrium shifts to the right. And when you decrease the temperature of an endothermic reaction, equilibrium shifts to the left. So it aligns with endothermic. So increasing the temperature of an endothermic reaction shifts equilibrium to the right. Decreasing the temperature shifts equilibrium to the left. So in this case, the temperature was decreased and it shifted to the left. So that makes the forward reaction an endothermic reaction. Okay, so the forward reaction is an endothermic reaction. All right, so that's very easy there. Next one, deduce the oxidation number of iodine in this. So the oxidation number of hydrogen is +1. And remember that the sum of the oxidation numbers should be equal, in a neutral compound, should be equal to 0. This is a neutral compound. It is not charged. So when hydrogen is +1, in order to make the sum of the oxidation numbers to be 0, iodine needs to be -1, so that everything sums up to be 0. So that makes iodine -1. Now, the next one, we see that one of the rules when calculating oxidation number is that the oxidation number of an element in an uncombined state is 0. Iodine, in this case, is in an uncombined state, so it's 0. All right, moving to the next one. All right, we have this reaction, and then choose from the list of elements that is most likely to be used as a catalyst. Recall from the knowledge of the periodic table that the most suitable element for being used as catalyst are the transition elements. All right, so they're the transition elements. So look at the options we have. This is a group 2 element. This is not a transition element. Carbon is not even a metal, and it's equally not a transition element. So the only transition element we have here is copper, and that makes copper the correct answer. State the effect on the position of equilibrium when the catalyst is used. So recall also that the catalyst does not affect the equilibrium position. So there is no change, or we say no effect, no change, or there is no effect on the position of equilibrium. State the effects that a catalyst has on the activation energy of a reaction. A catalyst simply lowers the activation energy. So it lowers the activation energy by creating an alternative pathway for the reaction to proceed. All right, so that's for that. So move to question 5. Lead 2 bromide is an insoluble salt and is made by precipitation. All right, so name 2 aqueous solutions that produce a precipitate of lead 2 bromide when they are mixed. Now, to make insoluble salts, remember that it has to be 2 soluble salts. So for you to obtain an insoluble salt, you need to mix 2 soluble salts together. 2 soluble salts will give you an insoluble salt. Okay, so knowing that, then there is the rule you also need to know on soluble salt. You need to know the rules of soluble salt. All right? So remember, SNAP is the rule for all soluble salt. Now, what do you mean by SNAP? S, sodium. Okay, so sodium, this is nitrate. This is for ammonium. And the P is for potassium. So it means all sodium, nitrate, ammonium, and potassium salts are soluble. So this will help us to select a salt now for this reaction to proceed, or for us to be able to form lead-2-bromide, which is insoluble. Okay, so we're going to make the salt from each of these cations and anions. So lead is a cation, so Pb2 plus, while the bromide ion is an anion, so Br minus. So from here, which of these can we pick to combine with lead to make one of the soluble salts? So we cannot pick the cations again because lead 2 plus is already a cation. So we need to pick an anion, which is nitrate, and that forms the first soluble salt. So we're going to have lead 2 nitrate. Okay, so we've gotten the first soluble salt, which has to be lead 2 nitrate. Now, we want to combine the next thing, which is the other anion, with another likely ion that could form a soluble salt. So this is an anion, so we cannot use nitrate any longer. We have to look for a cation. So we can either pick sodium, potassium, or ammonium. All right, so we could simply say sodium bromide. All right, to make it to make the two soluble salts that needs to be combined to form that. I believe that's very easy to do. So you need to know these rules. And then this is for the soluble salt. We also have a condition or a template for sulfates. We have a template for chlorides, and we have a template for carbonates. So you need to revise all of these templates before you go and take an exam. Describe how to produce a pure sample of lead-2-bromide from the mixture of aqueous solution. Since we are forming an insoluble salt, there is no need to heat it. So all we just need to do is to filter the residue. So filter the residue. After filtering the residue, wash with distilled water. Distilled water and dry in between filter papers. So this is how to obtain a pure sample of an insoluble salt. All right, write an ionic equation for the precipitation reaction which produces lead-2-bromide. All right, and you're asked to include state symbol. So this is very easy. So pick out the salt you want to prepare, which is lead-2-bromide. This is the formula of lead-2-bromide, PbR2. Split this into ions. So if you split this into ions, you're going to have Pb2 plus, Br minus. All right, so this is what we are simply going to write. Write these two ions as your reactant, and write this as the product, and include the state symbols. So write Pb2 plus. It has to be in the aqueous state. Br minus has to be in the aqueous state. And then we write the insoluble salt, which is PbBr2, which is in the solid state. All right, then we balance this equation. We have two bromine here, so it becomes 2. All right, so and that balances everything. So it's very easy. Split the insoluble salt into ions, write them as the reacting species, write your product as the solid that is being formed, and balance the equation, and then you get everything right. Describe a test for sulfur dioxide gas. So this is from paper 6. So the test is simply using acidified potassium manganate 7. So this is what we are basically going to use to do this test. That's the name of the test. And then you see that when you use acidified potassium manganate 7, it turns from purple to colorless. So that is the observation to test for sulfur dioxide. So you need to review some knowledge from paper 6 for this. All right, experimental techniques precisely. All right, the next question has to do with balancing of chemical equation. Immediately after the exams, a lot of students messaged me regarding this question because they had a challenge understanding that the two in front of this hydrated substance affects everything right here. All right, so when you know that, it will help you balance this equation. So let's dive straight into it. So on the left, we have 2 cobalts. So we simply put a 2 here. All right, now on the left, let's see how many nitrogens we have. So there is a 2 outside the bracket here. So 2 times the 2 at the coefficient here. So there are 4 nitrogens. So basically we should put a 4 there to make it also 4 nitrogens. All right, so moving to the next one, let's look at the number of hydrogens. Hydrogens there, we have, you can look at this. This is 4 times 2, 8. 8 here times the 2, which is the coefficient here. That's 16 hydrogens on the left. So to make 16 hydrogens here, all we need to do is put an 8 there. And just by doing this, you have balanced the equation. All right, if you check the number of oxygens, it's balanced as well. So that is how to solve that question. All right, so we have a question here on hydrated substance again. So the student is trying to determine the value of X. All right, the student weighs a sample of the hydrated cobalt 2 sulfate. The student heats the sample of hydrated cobalt 2 sulfate. The student weighs the remaining solid after heating. So describe what else the student should do to ensure that all the water has been given off. No other substances are required. All right, so what the student needs to do is to heat again. Heat again and reweigh until the mass is constant. So when the mass is constant, it tells you that you have given off all of the water and you have a dry sample. So that's basically what the student needs to do. All right. So moving to the question now, this next one, which is a question involving calculation. All right. So in an experiment, we see that we are asked to determine the number of moles of this. All right, we have the mass of the hydrated substance. We also have the mass of the anhydrous substance. That means some water has been lost, and that is why this mass is smaller compared to this, or lower in simple terms. So how do we calculate the number of moles of the cobalt 2 sulfate? So remember that the formula for number of moles is simply the mass divided by the molar mass. All right, so what's the mass of cobalt 2 sulfate is given to be 0.775. So 0.775 divided by the molar mass is 155. So I'll just compute that using my calculator. 0.775 divided by 155. All right, so I have 0.005. So it's as easy as that. Now, the next one is calculate the mass of H2O given off. So to get the mass of H2O given off, so mass of H2O or water given off will simply be what's the mass of the hydrated substance, which is 1.405, minus that of the anhydrous, 0.775. So let's compute this using the calculator. So 1.405 minus 0.775. So we have 0.63. So it's basically 0.63 grams. That's the mass of the water given off after it was heated. To get the number of moles of water, we remember number of moles of water is the mass of water, which is 0.63 divided by the molar mass of water, which is given already to be 18. So let's compute that as well. 0.63 divided by 18, and I have 0.035. So that's the number of moles of water. Now, the next one says determine the value of X. So to determine the value of X, all we need to do is to put the ratio of the number of moles of the cobalt 2 sulfate and that of water. So I'm going to put this and this into simple ratios, and then we divide by the smallest number. So we have 0.005 ratio 0.035. All right, so when we put those two things into ratios, remember this is that of the cobalt sulfate, and then this is that of water. All right, so the next thing is to divide by the smallest number. The smallest number here is simply 0.005. So divide by 0.005. So you're going to have 1 into ratio. So let's divide that. 0.005 divided by 0.035 divided by 0.005. So I have 7. So that means x is basically 7. So 7 is the answer here. So it's as easy as that. All right, so that is for the question on this. All right, you could watch the video over and over again to get how it was done. All right, let's move to the next question. This is on extraction. All right, the question is about metals, and then we have this diagram. All right, let's see the first question. Coke and iron are added at the top of the furnace. Name one other substance that is added at the top of the blast furnace. All right, we already see that hot air is also inserted at this point. So the other substance from your extraction of iron is calcium carbonate. So calcium carbonate is, or limestone, is what is added also at the top. Name the substance that leaves the blast furnace at A. All right, so the slag has a lesser density. So what should leave at A is the molten iron you are trying to obtain, or you have obtained rather. So it's molten iron. Slag is produced from an impurity in iron ore. Name the impurity in iron ore that is converted into slag. So your impurity is simply silicon 4 oxide, or you say silicon dioxide. So that's the impurity in the whole process. Name two substances that react together to produce the high temperature in the blast furnace. So what simply reacts together to produce that high temperature is coke. Okay, coke and oxygen. All right, so the oxygen is simply the air that is introduced into the furnace. Name two waste gases that leave the blast furnace. So the waste gases are simply from the impurities in the air as well. All right, so basically you would have carbon dioxide as one of them, all right, which is one of the gases produced in the blast furnace. All right, and then you also have some of the impurities such as argon. All right, is also there because it's present in the hot air. All right, next one, zinc is produced from zinc oxide in a furnace. Suggest why the zinc produced inside the furnace is a gas. All right, so the zinc is produced as a gas. It then forms molten zinc. So the reason why the zinc is likely going to be a gas is because the temperature in the furnace is higher than the boiling point of zinc. So if the temperature at the furnace is greater than the boiling point of zinc, zinc becomes a gas. So the temperature in the furnace, is higher than the boiling point of zinc. Higher than the boiling point of zinc. All right, state the name of the physical change that occurs when gaseous zinc is converted to molten zinc. All right, so when gaseous zinc is converted to molten zinc, that is simply condensation. All right, that's condensation occurring. That's the reverse simply occurring. So the reverse of boiling is condensation. All right, so that's very easy there. Zinc is used to coat iron to prevent rusting. Name the process used to coat iron with zinc as a method of rust prevention. Now, whenever zinc is used, you should know it is galvanizing. Galvanizing. So you're basically galvanizing. When the zinc coating is crushed, the iron underneath does not rust. Explain why the iron underneath the zinc does not rust. This is for 2 marks. So why the iron beneath the zinc does not rust is because zinc is more reactive than iron. Zinc is more reactive than iron. Therefore, it oxidizes and it oxidizes to form a shield that protects the ion. All right, so that is the two reasons why zinc. Those are the two reasons why the ion underneath the zinc does not rust. First, you have to state that the zinc is more reactive, and because the zinc is more reactive, it oxidizes ahead of the ion. Okay, so that is how to give answers to that. All right, so zinc oxide neutralizes both acids and bases. State the general name given to oxides that neutralize both acids and bases. So from your knowledge of acid, bases, and salts or oxides, we have the acidic oxides, we have the basic oxides, and we have the amphoteric oxide. So from the knowledge of amphoteric oxide, you see that they do not, they neutralize the acids and bases. So in some cases, they can act as an acid, and in some cases, they could equally act as a base. So we have aluminium oxide as an example there, and we also have zinc oxide, which is what we are looking at. So these are amphoteric in nature. When zinc oxide neutralizes aqueous sodium hydroxide, so we have to write the formula of sodium zincate. So Na plus is in group 1, so sodium is in group 1, and this is the zincate ion, 2 minus. So like we said earlier, they interchange their powers excluding the charge. All right, so this simply becomes Na2, all right, ZNO2. Okay, because this is 1, so anything multiplied by 1 is simply that same coefficient, so it doesn't really have an impact. All right, so that's the correct formula of sodium zincate. Name the zinc compound that forms when zinc oxide neutralizes dilute sulfuric acid. So basically, when you have zinc oxide reacting with sulfuric acid, you're going to form a salt, are going to form water. So in this case, since you are dealing with sulfuric acid, you're going to form a salt that contains the sulfate. So basically, it's going to be zinc sulfate, right, due to the sulfuric acid composition there. All right, so I think we're getting to the end of this paper. All right, now the next question has to do with empirical formula. All right, this is also a bonus question. So we have carbon and we have hydrogen. So we have this to be 82.76 and we have this to be 17.24. So consulting the periodic table, you see that the molar mass of carbon is 12, that of hydrogen is 1. So let's divide now. So it's going to be 82.76 divided by 12, and I have 6.89, let's say 6.8966, all right, just about that figure. And this still remains 17.24. So let's simply make these two decimal places as well. So I'll simply erase this and just make it 6.9. All right, so I'm going to make it 6.9. So 6.90. All right, so from here now we can simply divide by the lowest number. So divide 6.90, 6.90. So this becomes 1, and then we have 17.24 divided by 6.90. So we have 2.4, all right, which is like 2.5 right there. All right, so we have 2.5. All right, so since we have a 0.5, whenever you have a 0.5, all you need to do is to multiply by 2. So if we multiply that by 2, we are going to have 2 ratio. If we multiply this by 2, you're going to have 5. So the final empirical formula is C2H5. So the rule is whenever you have a 0.5, just multiply by 2 to make it both atoms by 2, and that's that. All right, so we have a compound B has empirical formula of CH2 and the relative molecular mass of 70. Determine the molecular formula. So we have CH2, so C is 12 plus hydrogen is 1 times 2 all into n equals to 70. All right, so we add this up, so it's 12 plus 2 all into n equals to 70. All right, so we have 14n equals to 70. All right, now in this case, so all we need to do is to divide by 14. So we divide by 14 and divide by 14, and 14 divided by 70, so n is equal to 5. So if n equals to 5, so we have CH2 n, so that's simply saying CH2 all into 5. So it becomes C5H10. All right, so that is how to solve that question. All right, now moving to this question is on polymers. All right, now draw the displayed formula of the monomer that forms polymer Q. So what you need to do in questions like this is to look at what unit is being repeated. So if you look at this, this is 1 unit, and then look at this. This is the second unit. That means we are dealing with an alkene, because when you have just carbon hydrogens, that should tell you that you are dealing basically with an alkene. So when you know that, all you need to do is to pick out one of the units. So pick out one of the units that is repeated and put a double bond in between the two carbons. So I'm going to pick out one of these units. So I'll have something like this, C. Okay, so I'll put a double bond in between, and then I complete it by putting the atoms attached. So we have CH3 right here, we have H on the first one, and on the other one we have CH3, and we equally have H. So this is the monomer that gave this. It's as simple as that. So like we said earlier, pick out, know what unit is being repeated, pick that out. Since you are dealing with only carbon and hydrogens, it is definitely an alkane, so it's an addition polymer. So all you just need to do is to put a double bond in between the two carbons and remove these continuation bonds off, and then attach all the atoms that should be there. All right. Now the next one says name the monomer used to form polymer Q. All right, so we're asked to name this monomer. So to name this monomer, I'm going to be using a different color of ink so that we can do a proper numbering. All right, so we're splitting number this way. So this is 1, 2, 3, 4. All right, then you use another color of ink to number backwards. So I'm going to use the blue ink this time. So this is also 1, 2, 3, 4. All right, so when you have 4 carbons with a double bond, that is butene. Okay, that's butene. 4 carbons with a double bond, that is butene. All right, so the next thing is to identify the position of the double bond. Now, when you're naming, remember that you give priority to the lowest number. So we're looking at 2 likely numbers, either 2 or 3, just by looking at the double bond position. So either you pick position 2 or you are looking at position 3. But the priority is to give preference to the lowest number. So we're going to go with the lowest number here, and therefore this monomer is going to be named but2-ene, not but3-ene, not butene. So just by numbering, you see that the position of the double bond is directly attached to the second carbon, and that solves this question. Okay, so that is how to go about that question. Okay, so we move to the next question. I think we are almost there with the paper. All right, so we have propene can be produced by heating this. These are the product of the reaction, 1:1:1. All right, so complete the symbol equation. Now, in this case, you are cracking a larger alkane, and whenever you crack a larger alkane and you have hydrogen produced, the other 2 substances must be alkenes. The other 2 substances must be alkenes. So that means to fill in this gap, and we need to fill in an alkene. So let's sum up. There are 3 carbons here. So 11 minus 3, that's about 8 carbons. All right, then let's look at hydrogen. There are 8 hydrogens on the right. So 8 minus 24, that's about 16 hydrogens. So let's confirm if this is an alkene. The general formula of alkenes is CnH2n. So C8H16, and that's what makes this a correct formula. So whenever you're cracking a larger alkane, you're supposed to produce, either you produce just 2 alkenes or you produce alkenes and hydrogen. Right, so that's how it works. Okay, so this next question, we have carboxylic acid and esters contain carbon, hydrogen, and oxygen only. All right, X and Y have the same molecular formula. State the name given to compounds with the same molecular formula but different structural. So that should tell you that there are isomers. All right, so isomers are compounds with the same molecular formula but different structural formula. Okay, so esters are made by the reaction between carboxylic acid and alcohols. Ester X is methyl ethanoate. All right, name the carboxylic acid and the alcohol used to make methyl ethanoate. So whenever you see an ester, first thing you need to do is know that the first name here is the contribution of the alcohol. And the second name here is the contribution of carboxylic acid. This is the first thing that you should do. So the first name there is the contribution of the alcohol. The second name is the contribution of the carboxylic acid. So from here, we can extract the carboxylic acid. So since this is ether, so it becomes ethanoic. Right? And then since this is meth, it becomes methanol. That is how to go about that question. All right? I believe it's very easy.
This is what we do in the masterclass, really. We try as much as possible to ensure that we're able to properly, right, teach learners how they can properly understand, interpret the question as much as possible. We dive deeper than just a past paper to ensure that at the end of the day, they're able to fully understand any question that is being administered to them.
So the last one here says, draw the displayed formula of carboxylic acid Y. All right, so we're asked to draw carboxylic acid Y. Okay, knowing that it contains 3 carbon atoms. So the carboxylic acid we are simply drawing is ethanoic. All right, so let's draw. So remember the general formula of ethanoic acid. General formula of carboxylic acid is CnH2n plus 1 COOH. And then we're already told that this contains 3 carbons, okay, from what you already told here. Okay, you already told that ester X and the carboxylic acid Y both contain 3 carbon atoms. All right, so when we put N, that means N is 2. So when we put N here, it becomes C2H4 plus 1, that's about 5 COOH. All right, so just by looking at this, we can now draw the formula of the carboxylic acid, all right, because it needs to contain 2 carbon atoms. All right, so from here, we could simply draw. So we're going to draw the displayed formula of this, since we have the total number of carbons now to be 3. So it's going to be something like this: 1, 2, 3. All right, so we draw the carboxylic acid functional group. So we draw that, it becomes something like this: C double bond OOH. So this is that of the carboxylic acid. All right, so now let's attach the hydrogens that are there. So we should have 5 hydrogens. So 1 right here, 1 right here, 1 right here, 1 right here, and 1 right here. So these are 5 hydrogens aligning with the formula. So this is simply 3 carbon atoms. So 3 carbon atoms of the carboxylic acid group is called propanoic acid. All right. So the first member of the carboxylic acid is metanoic. That's 1 carbon atom. The second member with 2 carbon atoms is ethanoic. So the third member is simply propanoic with 3 carbon atoms. All right, so these are the solutions to this paper. So you could watch it, share with your friends, and then continue to subscribe to this YouTube channel. Thank you for watching.